Today's video about importance of some supplements, and first part would be about Fisetin. In eukaryotic cells, energy can be generated by converting glucose to pyruvates in the cell's cytoplasm. During this conversion, two ATP molecules are created for every one glucose molecule, and two NADH molecules are made. NADH must be regenerated to NAD+ in order for the process to continue. This can occur in anaerobic fermentation process with lactic acid production in the cytosol. Alternatively, NADH can be transferred to the mitochondrial respiratory electron transport chain for aerobic energy synthesis, energy in form of ATP molecules, via oxidative phosphorylation. Mitochondria are the organelles of aerobic respiration and energy synthesis as ATP molecules from fatty acids, amino acids, and pyruvates. Okay, here every cell, almost every cell, the only cells that don't have mitochondria, it is red blood cells. All other cells have mitochondria, and the more mitochondria they have, the more energy they can produce, and it's like heart, liver, and kidney. They have a lot of mitochondria in the cells. Okay, this is the structure of mitochondria. It is a relatively complicated organelle, and so it is. But it is very important. Number of this mitochondria can vary. It depends on conditions. Okay, so energy can be produced, as I said, in cytosol, and it is from glucose, only from glucose, not from amino acids and fatty acids. So, and glucose can be split to two pyruvic acid molecules or ions. And then what is happening, two ADP molecules two more ATP molecules are here consumed, and here four ATP molecules are released. So in net, it is two molecules of ATP are produced, and then this is conversion of NAD+ to NADH, and also ions of hydrogen, cations of hydrogen. Okay, lactic acid, here lactic acid, so pyruvic acid can be converted to lactic acid, yes, further. And this process is going, for example, in red blood cells. And then blood with this lactate ions can go to liver, and liver, by using energy from burning fat mostly, it can recycle lactate to glucose in two steps. So first pyruvate and then glucose. And then glucose gets back to blood and can be used by cells as a source of energy. Okay, this is the process. And as we age, our blood vessels are getting gradually more stiff, and the supply of oxygen to tissues is reduced. In conditions of oxygen shortage, this is hypoxia. Normal cells use anaerobic glycolysis in cytoplasm to produce energy following suppression. So after suppression of this oxidative phosphorylation in mitochondria. Intermittent acute hypoxia may lead to transition of some normal cells into senescent or so-called zombie cells. Senescent cells are metabolically active cells which produce and secrete messenger proteins. This is so-called a senescent associated secretory phenotype. And the release of this SASP leads to local inflammation, dilation of blood vessels, and accelerated production of collagen by fibroblast cells. When the local density of collagen fibers and stiffness of the extracellular matrix increases above some critical level, some of the fibroblasts stop producing collagen and in turn transform into acute senescent cells. These acute senescent cells orchestrate their own elimination by secreting SASP in large amounts that attract different types of immune cells. In macrophages in particular move to the area, eliminating senescent cells and destroying excess of collagen. The similar chronic hypoxia of tissue causes an increase in the number of normal healthy cells to enter the zombie state, and increase in the release of SASP. And then SASP, during chronic hypoxia, causes chronic inflammation of the tissue, increases the likelihood of neighboring cells into becoming senescent. In response to the chronic inflammation, fibroblast cells create collagen because it's normal mechanism. And so the excessive stiffness of the tissue develops, resulting in tissue fibrosis. In the fibrotic tissue, immune cells migration is impaired. Therefore, senescent cells cannot be eliminated and they accumulate. So this slide presents structure of the macrophage. You see it is specialized cell that is killing bacteria and killing some senescent cells and some other malignant cells. And it is highly specialized. It is getting energy from protein. So it is, again, cannot use glucose, and it does not using this macrophage. It is not using glucose, but it is getting energy from proteins. And then in lysosomes, there are enzymes, and with these enzymes, the content of the lysosomes is digested, and some nutrients are produced. Some part of these nutrients are used by the macrophage, and part is excreted to the extracellular matrix and used by stem cells to grow. Okay, here schematically presented transition of normal cell into senescent cell. And under stress mostly is oxidative stress. We will talk about this later. But also it can be a result of inflammation and hypoxia. Hypoxia leads to oxidative stress. Okay, if number of senescent cells grow uncontrollably, then we have all these complications like cancer, aging, and fibrosis of tissues, and the most dangerous is pulmonary fibrosis of lungs. Or if it is if immune cells work properly and they can eliminate senescent cells, then it is all fine. So it is, then we have rejuvenation of our body, and because not only senescent cells are killed, but also the excess of collagen is removed. Okay, hypoxia, as I said, is conditions that occur when there is a decrease in the availability of oxygen in the body. When cells are deprived of oxygen, there is a decrease in the production of ATP molecules, adenosine triphosphate, by mitochondria in eukaryotic cells. This decrease in ATP production can lead to mitochondrial dysfunction, which can contribute to the production of reactive oxygen species and oxidative stress. Mitochondria are primary source of reactive oxygen species in cells, which are molecules, and these reactive oxygen molecules are mostly hydrogen peroxide. So, and these molecules can cause cellular damage of membranes mostly, but also of DNA, and if they are not properly suppressed. Under normal conditions, mitochondria produce small amount of reactive oxygen species as a byproduct of aerobic metabolism, which is the process which cells convert nutrients into energy. However, when mitochondrial function is disrupted, such as like during hypoxia, there is an increase in the production of reactive oxygen species. And the suppression of the electron transport chain is the one mechanism in the mitochondria, by which hypoxia can lead to increased generation of reactive oxygen species. When oxygen levels reduced in the tissue, then this electron transport chain is inhibited, so it is mitochondria cannot produce energy. And this results in an accumulation of electrons that can react with oxygen to create reactive oxygen species. Furthermore, hypoxia can cause activation of enzymes that generate reactive oxygen species. The increased generation of reactive oxygen species during hypoxia result in oxidative stress. So it is actually more reactive oxygen species, the more is oxidative stress. And this is, as I always talking, it is imbalance between production and ability of the cell to eliminate reactive oxygen species with antioxidants. Okay, then reactive oxygen species, they have ability to harm biological components such as lipids in membranes and phospholipids and proteins and DNA and polyunsaturated fatty acids and mitochondria. And mitochondria especially very susceptible to destruction by reactive oxygen species, and their damage causes cellular malfunction and may transform normal cells into malignant cells, which are cancerous or senescent cells. Okay, here we have a slide demonstrating us difference between normal mitochondria, healthy mitochondria, and mitochondrial dysfunction as a result of the hypoxia, for example. And this protein number 1 is complex 1 is generate reactive oxygen species, and this reactive oxygen species they damage membranes in the mitochondria. Also, what is happening, calcium transport of calcium inside the matrix of the mitochondria is increasing, and we have too much calcium inside. Okay, then aerobic glycolysis in malignant cells improves elevated glucose uptake. Involves elevated glucose uptake. Yeah, because again, energy is getting only from glucose. Other nutrients like amino acids, fatty acids cannot be used in the cytoplasm to produce energy, only glucose. So, and if some people have type 2 diabetes, and therefore they have high level of blood glucose, they have also increased the risk of developing cancers and then accelerated aging also. Okay, then we are coming to a little bit, next we will do it again. This is about Fisetin. Maybe I will jump a little bit and okay, and then we'll return to the slide. So plants cannot escape their enemies, which are insects and animals that harm or consume them. Therefore, they create and employ toxins to boost their chances of survival. Toxins are abundant in plant seeds, especially in plant seeds, as all living things strive to protect their babies. Most toxins are alkaloids, which are chemical compounds with at least one nitrogen atom per molecule, and they are frequently heterocyclic. Some alkaloids can be employed as stimulants like cocaine and caffeine, and hallucinogens, it is like mescaline, morphine, and psilocin, or it can be bioenhancers in low quantities like berberine, piperine, Fisetin, and quinine, etc. And plants, in addition to alkaloids, produce flavonoids, which typically comprise 2 phenolic rings and 1 heterocyclic ring containing oxygen. Okay, as I said, plants produce a lot of different toxins to protect themselves from herbivores and other insects that are eating them. Flavonoids are important components of the cells of all higher plants. Plants evolve to produce flavonoids to protect against fungal diseases, pathogens, ultraviolet radiation, etc. And flavonoids are best known for their antioxidant activity, and so it can be health benefits from cancer and heart disease. And widespread availability of flavonoids, their diversity, and their relatively low toxicity compared to other active plant compounds like alkaloids means that many animals, including humans, can consume significant amount of them in their diet. They are anti-allergic, anti-inflammatory, antimicrobial, and anti-cancer drugs. Consumers and food manufacturers are shown interest in flavonoids for their medical properties, especially because of their potential role in the prevention of cancer and cardiovascular disease. There are around 5,000 flavonoids known, and these are flavonoids, flavonols, and flavones, and this is like in tea, onions, and apples. Catechins in tea and chocolate, flavonones in citrus fruits, and isoflavonoids, it is in soybeans and legumes, and anthocyanidins, it is like in berries, and this is six subgroups. Flavonoids are poorly absorbed from the intestines into the blood, and bioavailability less than 5%, and they are rapidly processed by the liver and eliminated in the urine within 14 or maximum 16 hours. Flavonoids can be transformed by bacteria in the colon into aromatic phenolic acid, which can then reach the bloodstream. Because the concentration of flavonoids in the blood always cannot be very high, it's always low, bioavailability is very low. It is probably that the byproducts of the flavonoid breakdown by bacteria influence our body too. Okay, here we have this slide presenting how polyphenols in plants can be classified. So phenolic acids, flavonoids, and non-flavonoids, and etc. So we have some number of classification. And over here in the table we see this six classes: flavonols, and flavones, isoflavones, flavonones, and flavonols. Okay, sorry, it's again, but okay, you can read it yourself. And the sources and examples of these flavonols. Okay, when consumed, flavonoids accumulate in mitochondria, which are important organelles in our cells, and slow down their work. As a result, the metabolic rate drops in the cells, and the mitochondria produce many reactive oxygen species. Again, cells with high metabolic rate, which use glucose as the main source of energy, suffer the most. These are cancer cells, zombie cells, and senescent cells. And zombie and senescent cells are the same, and cells affected by viral infection. To maintain homeostasis, the cell nucleus commands the production of natural antioxidants, glutathione, and more mitochondria. But again, to do so, cells need to make proteins in ribosomes. This is important organelles, other important organelles in our cells. But if you take flavonoids together with fasting and physical activity during the fasting, then the level of glucose and amino acids in the blood are low, and therefore protein production process and production of new mitochondria is blocked, and the cell go into self-cleaning or autophagy mode. So instead of producing the proteins. So okay, you see that how flavonoids work. They accumulate in mitochondria, slow down, and if it is hyperactive malignant cells, then for them it is results in high production of reactive oxygen species. Okay, then we will talk about Fisetin, and Fisetin is a bioactive plant flavonoid that originally isolated from this plant. You can click on the link, and a link in the description to this video. It is common in herbal teas and strawberries, and it can be extracted with methanol, water, and supercritical fluids. Fisetin has a number of biological actions in human body, including antioxidant, anti-inflammatory, and anti-cancer properties. And for example, there was publication in zebrafish model Fisetin promoted mitophagy, inhibit its buildup of damaged mitochondria, and reduce level of rectin oxygen species generation by mitochondria. But again, it is in normal cells. Fisetin possesses direct antioxidant activity as well as ability to enhance intracellular level of glutathione in primary intracellular which is the primary intracellular antioxidant. Obviously, if we add some potent antioxidant, then we are saving this glutathione. Okay, Fisetin reducing to about half the breakdown of glycogen into glucose, phosphate, and glucose, as well as conversion of glucose into pyruvate and lactate. So Fisetin suppressing glycolysis, okay, glycolysis and production of glucose from glycogen. This is important. Okay, this is important to block it, to starve the malignant cells. Okay, so here at this slide we see the structure of Fisetin and quercetin, which are very common, and they are quite similar. And then we have also another like rutin, mostly in plants and berries. We have rutin, which is actually Fisetin, but with sugar molecules. Okay, then we'll jump a little bit back. Unfortunately, the structure of the presentation is not so optimized. Okay, Fisetin supplementation suppresses production of all energy in malignant cells. So this is what I was talking always, that it is suppressing glycolysis. And also Fisetin inhibits cell proliferation and induces apoptosis in human gastric cancer cells by increasing generation of rectin oxygen species, specifically through the complex 1 of the electron transfer chain in mitochondria of cancer cells. It also increases cellular nitrite and superoxide generation. Okay, Fisetin shows cytotoxicity in human oral cancer cells, and it also functions as a senolytic in laboratory cells cultures with less toxicity than existing senolytics such as Novitoclax. Okay, the Fisetin, as I said, it is relatively safe. It's senolytic and senostatic. Okay, here as we see, the normal cells glycolysis can produce from glucose. It can produce pyruvate, and pyruvate go further by fermentation to lactate, and the lactate, as I was showing before, can be recycled in liver, or otherwise pyruvate go to mitochondria and burning, producing water and carbon dioxide. In tumor cells, in malignant cells, it is different because glucose, mostly energy produced by glycolysis, and so glucose gets converted to pyruvate, and it can go to mitochondria. It is not so that all malignant cells completely suppress this oxidative phosphorylation. No, it works, but it is somehow dysfunctional. It is producing a lot of rectin oxygen species, but also in principle it generates some number of ATP molecules. Okay, so we jump a little bit further. Fisetin demonstrated the highest activity and selectivity as a senolytic drug in mouse experiments, at least in adipose tissue and subcutaneous fat. Out of 11 flavonoids tested, it is like resveratrol, Fisetin, luteolin, rutin, epigallocatechin, gallate, curcumin, etc. So Fisetin is really special, and Fisetin inhibits the release of pro-inflammatory cytokines, such as what normal in the SASP. And for several days after taking Fisetin, the concentration of these pro-inflammatory indicators decreased, and then we can think what is the reason. and the half-life of fisetin in serum in blood is less than 3 hours. And but we see the impact with his change for several days. So it can be explained that this advantage not depend on the presence of fisetin in the blood for all times, but maybe it works as a senolytic and kills senescent cells or suppress activity of the senescent cells so much that that we see this positive impact. Okay, interesting that again melatonin coupled with fisetin has been demonstrated to dramatically increase anti-cancer activity when compared with fisetin alone. Okay, fisetin and melatonin, two antioxidants, potent oxidants, if they combined, then it gives much better impact. So it is synergistically, they can be work synergistically. And in vitro, in vivo, combination of quercetin with fisetin also gave a substantial synergistic impact against human breast cancer. No adverse effects of fisetin has been reported, even at high doses of fisetin and quercetin taken together. Okay, the fisetin itself eliminates 25 up to 50% of the senescent zombie cells, depending on the organ and method of assessment. But its usefulness as a senolytic drug is higher. Senostatic drug is higher than a senolytic. Okay, so it may kill senescent cells, but mostly it is suppressing activity of the senescent cells, activity in production of this SASP, senescent secretory phenotype. Okay, an analysis of available clinical data revealed that oral administration of fisetin in elderly can restore tissue homeostasis, reduce inflammation, and also reduce risk of development of many forms of cancer. Okay, we see this combination of two antioxidants, melatonin and fisetin, shows much better result, but also fisetin with quercetin, they have almost similar structure, and together they work better than separately. In healthy cells, fisetin increases mitochondrial ATP production, so it is interesting. In hyperactive, fisetin slow down, and that actually disrupts production of ATP in mitochondria, and instead many reactive oxygen species are produced. But in healthy cells where they are not very much active, they burn in other nutrients like fatty acids, and fisetin increases production of ATP because it activates this electron transport chain complex 1. Okay, fisetin promoted hair growth in mice by activating the transition from telogen to anagen in hair follicle, but was oral. Fisetin was used as oral supplement. Okay, again, oral supplementation of fisetin improved vascular endothelium function in elderly. In elderly mice, male mice, by decreasing cellular senescence, scavenging excess of reactive oxygen species, and boosting nitric oxide bioavailability. So it is dilation of the blood vessel. Fisetin treatment to wild type mice at a later age regulates SASP and enhances mean and maximum longevity. So again, fisetin is a very useful supplement, in difference to many others, because many others don't show any improvement, but fisetin works really, especially if it is combined with quercetin or combined with melatonin and other bioenhancers. It can also it has also been shown that fisetin improves heart function, decreases the degeneration of pro-inflammatory cytokines, and prevent that fibrosis, arterial fibrosis, following an acute myocardial infection in rats. In obese mice, Fisetin inhibits metabolic degenerative illnesses associated with chronic inflammation, particular tissue fibrosis and insulin resistance. Again, fibrosis develops because of inflammation, chronic inflammation, and if we consume, we or animals consume Fisetin, then development of fibrosis is kind of decelerated. Fisetin reduces wrinkles and smooths the skin by enhancing the flexibility of extracellular matrix. Okay, this is not easy to understand why it was working so, but okay, mechanism is not known, but okay, but many people report that skin is getting better if take Fisetin in some doses every day or with like 2 days and some with interval 1 month between the taken Fisetin. Okay, according to the Mayo Clinic protocol, women should take oral Fisetin at a dose about 20 milligram per kilo of body weight, 2 days in a row, and with 1 month break in between. The doses. And for males, a little more is needed because the prostate gland absorbs Fisetin and you need to add 500 milligram or more. It means to take like 1 gram 50 milligram for 500 milligram for quite massive body mass of a man's 100 kilo. It is obese people. Okay, however, problem with Fisetin that limited solubility and bioavailability are important drawbacks which can be overcome through some co-crystallization, complementation with cyclodextrins, and encapsulation with nanoparticles. Okay, Fisetin absorption is improved by certain oils like coconut oil, olive oil, fish oil, and so it is better to take Fisetin with meals rather than on empty stomach, and this can improve bioavailability. Also, recently it was published that almost 10-fold enhancement in oral bioavailability was get by combination of Fisetin with fenugreek. Fenugreek creates some kind of gel, and so that Fisetin stays longer in the guts, and also it is not much destroyed in the stomach. Okay, so again, I do this video only to express my personal opinion. I'm not a medical professional, of course. So, and the visitor is advised to discuss the content of this video with his or her personal physician. And again, I cannot take any responsibility, and this is not advising or to do something, but I do it because, and all what I am learning, and I use and I try on myself, but if it works for me, it may not work for you. Everybody is special, everybody is unique. Okay, then thank you for taking time to watch the video, comment, subscribe, like, ask questions and share information, and have a wonderful day. Ciao, ciao.